Good morning, everyone. How's everyone feeling? That's pretty good. Not bad. I'm glad we're not after lunch because that would be a lot less enthusiastic. So, cool. So, yeah, I'm Mike McCabe. Brian, we'll do some more intros in a minute. But so today we're talking about startup security, and what that means to us. To get started, what the fuck is security, and how to ignore it and deliver your project? That's pretty much, from my perspective, what a lot of startups see security as. And so we're trying to kind of change that and go from how to ignore it to how to automate it. And so what is the problem with security in general? I think we all know security is pretty hard. It's impossible to be completely secure. It's usually slow. Tools are expensive. The process can be expensive. And startups are kind of the opposite. They want to move fast. They are results focused. They want to put out features as quick as possible, products as quick as possible. And they're spending adverse before they get VC money, and then they go crazy and get ball pits and everything like that. So that's kind of the problem space we're working in. And to kind of take one step back. So I'm Mike McCabe. I'm a consultant, developer-ish, and kind of ops person at Stratum Security, and this is Brian.
Hey, I'm Brian Henderson. I'm the Director of Architecture for Xfil, one of Stratum Security's products. I'm also a developer, consultant. I work in DevOps, pretty much wear all the hats. And so we both work for Stratum Security, and what is Stratum Security? Well, traditionally we are a small, boutique security consulting firm. And we focus primarily in the application security space. But we've also had the unique opportunity of bootstrapping our second product now, Xfil, and we've had the experience of bootstrapping our first product, ThreatSim, selling that off a few years ago. So we've kind of been working in this space while Stratum's been around for a few years, probably about 10 to 12. We kind of work and operate in a startup mode. Over and over and over again. So what is Xfil? So Xfil is a new product that we're working on. We won't be talking too much about it, but I'll give you some context about what Xfil is, just to sort of define the space that we're in. So Xfil is a post-compromise simulation platform, sort of simulating breaches, nation-state actors, that sort of stuff. The idea is to test all your assumptions behind all the controls and technology you have in place to protect yourself. It runs an agent software inside your network, executes malware indicators, exfiltrates simulated data, does all sorts of things that a threat actor might do, but in a benign-ish way. And in the end, customers can obviously view the results in the dashboard, track and trend data, that sort of stuff. So what are some of our challenges? Well, we're a really small group of developers. There's, I think, 4 of us, if you count Mike and I as half-time on actual writing code and development. We have a young group of talented people, but we're a small group. We have a lot of short timelines. We're 100% bootstrapped, so we need to get to the point where we're generating revenue quickly. So that we're not sinking all the cost into development. We're working in the space of a lot of new technologies and leveraging some bleeding edge stuff that there's really not a whole lot of security tooling for, and that's definitely a challenge. We leverage Amazon Web Services, which is great for getting started quickly, but you can, as we'll kind of talk about later, everything that it offers you can really get out of control. You can lose track of what you've got in there, what you've been working on, and it's really hard to kind of rein that back in and make sure that you're doing the right thing with the right services that you're using. Lastly, or almost lastly, Xfil works with some interesting custom network protocols that we've developed in order to simulate, threat actors, we need to act like them. We need to pretend to be them, and we need our services to act like them. So, just for instance, one of the things that we do is we exfiltrate data through ICMP. And so we've got listeners on the internet that accept data through ICMP, and we need to make sure that that's protected in such a way that we're not compromising customer data. Lastly, we need to deal with the challenge that I think everybody deals with when developing and deploying applications is, what do you do with secrets? And so we'll talk about that a little bit too.
Yeah, so our solutions are kind of broken up into two different sections. We kind of talk about the application security side of things and the AWS side of things. But I mean, this conference has been talking about building security and automating it for a long time. And that's kind of what we adopted for our solution is, everything is CI based, and we'll talk about that. We're pushing code all the time. Everything's running through tests. So we're trying to build security into that wherever possible. We're a security consulting company. The last thing we need is, for our product to be hacked. And we've been doing this for a long time. So we kind of understand we have to build security in order to make it actually work. But kind of like what Brian talked about, there aren't a lot of great tools for the technologies that we're using. So we've had to kind of bootstrap some things of our own and figure out what's out there and use it. We don't want to spend a ton of money. We're not going to buy, Fortify or Veracode. We don't have thousands of dollars to spend on those tools every year. And so we're kind of doing things on our own using tools that are out there. And we do continuous testing. We're going to talk about AWS hardening and alerting as well. So we're only talking kind of part of what a startup should worry about. There's also a whole host of other things. Here's some of the things that we don't cover. Host security, super important. Everyone should be encrypting their laptops. You probably shouldn't be running Kaspersky anymore, but something on your laptops. MDM, your office security, of course, is important. Incident response, disaster recovery. Those are all important topics. They're not really what we're going to get in today. We're focusing mostly on the application security and cloud security side of things, but those are some of the things that startups do have to kind of focus on.
Yeah, before we get too far, we're just kind of want to give you guys an overview of the technologies that we use. So we, as I've already mentioned, are very heavy in Amazon Web Services, and we actually use a lot of their services outside of like EC2 instances and that sort of thing, especially in facilitating a lot of the automation that we talk about later. The one tool that we actually do spend money on is CodeShip. There are other CI/CD platforms out there that can service just as well, and all of our applications, are built on containers. So we're very heavy users of Docker. The great thing for us is it allows our developers to kind of develop as if they're in a production environment. It allows us to test in a development environment as if it was a production environment. Developers can run security tooling and all that sort of stuff on their local machines before getting it through the pipeline and catching things there. So yeah, that's just a brief overview of the technologies that we're using.
Yeah, so to dive into kind of the application security side, that's kind of the world I've been in for the past 5 or 6 years. It's kind of the area that I focus in the most. So here's some of the languages that we're using. Most everything now is JavaScript and Golang, which couldn't be more polar opposites in terms of kind of personality of languages. We were using Rust for a while, which our developers really liked, but kind of slowed things down, so we moved away from it. It has a lot of great advantages, but it's still, there's not enough folks out there who know Rust, and it has slowed stuff down for us, so we kind of moved away from it and just using JavaScript and Go. And so with that, JavaScript's not new, but for some reason there's still not a lot of great security tooling for JavaScript. Go is newer, but again, there's still not a lot of great security tools for either one. I've used all the commercial tools on these languages that support them, Veracode, checkmarks, and the results just aren't really there yet. So we've kind of had to figure out other ways of approaching security for these languages. And like Brian talked about, there's unique security challenges when you're building your own custom network protocols. I mean, we're taking FTP, SFTP, TCP, and we have code that's parsing all of that data that's sitting out there on the internet. You could go throw data at it right now if you wanted to. But that's just a requirement for how our product works. We have to have that out there. And yeah, developers push code all day. I mean, we have PR process, which we'll talk about, but we empower our developers to write code and get code out to the environment. And so we don't want to slow the process down. We want to build things in, and we want to advise our developers how to make things more secure without slowing them down, stopping them, and creating a whole kind of mess because security needs to weigh in on things. So some of the solutions that we found for the language security side of things, linting. Linting has been around forever, but we have a pretty rigorous kind of set of linting that we do just from a stylistic and kind of code quality perspective. But we also started building linting in from a security perspective as well, because again, with JavaScript, there aren't a lot of great security tools, so we kind of took what's out there and we use that as kind of our SCA, as our static analysis for JavaScript. Fuzzing again has been around for a long time, but it's gotten a lot more popular. And we use that for some of our kind of custom network protocol stuff. There's a tool out there for Go, which we kind of experimented with. Don't know if it has a lot of great results yet, but I'll talk about that a little bit. And then automated dynamic testing, building that into our pipeline, and dependency checking in our pipeline. And we'll kind of dive into that a little bit more. So from the linting perspective, we use ESLint just for code quality overall. There's also a security plugin made by Adam Baldwin. If you guys are familiar with the Node Security Project, he runs that. There's an ESLint security plugin. And it has a bunch of different rules built into it. And really, we see it as kind of a baseline for security when it comes to JavaScript. It's not going to find everything. It doesn't do flow control or flow analysis. It doesn't do real static analysis. But it'll find low-hanging fruit that your developers might enter into the code. So things like unsafe regexes, child process, weak randomness, all those kind of things that are easy to pick up just based on methods that are being used, we implement that in the code so that we can see in the build time if someone's added some potentially vulnerable code. And so yeah, this runs in the CI, which is code ship, and breaks the build if something pops up. And then once that happens, we start a discussion of why is this being used? Is there an actual legitimate reason, and what are the guards in place for that? So this is just a quick kind of example of one of the rules for the ESLint security plugin. You don't need to dive too far into it, but more or less what it's doing is looking for the use of child process in JavaScript. And if it's being used, it's going to return an error that says child process is being used. Generally, for us, we're not doing process management inside of our Node application. So if we see something like this pop up, it's probably a really bad practice. It's not part of our architecture. And so we have this built into our CI pipeline. We have a lot of other linting checks there as well. But basically what we've been able to do is put security, even though it's a kind of a basic form of security for JavaScript, we've been able to build that into the pipeline, build that into the normal CI process that we'd have anyway, even if we weren't doing security checking. And so you can see we have a bunch of errors right now that we have to kind of get through, but we have this running and we have it stopping builds if we have it enabled. So some of the downsides of linting though, super high false positives. It's regex, that's all it is at the end of the day. But what is static analysis but regex? No vendor's going to admit that, but so there's high false positives. It's looking for basic things. So you really have to start slow with it. You can plug in different rules at once. We don't use all the rules right away. We use kind of the basic ones that we know won't throw up a huge amount of errors. So things like regexes or child process or weak randomness, we have those included so we know that if those are going to be added to the code somewhere, we'll get flagged for that. And the big thing for this is you can't just turn this on in the build pipeline and then just throw it over the fence and say like, here's 10,000 errors, devs, you need to go address that because they're all going to be false positives. And there's no faster way to get your developers to ignore security than by just throwing a bunch of false positives over the fence and saying, you guys deal with it. So that's kind of the Winting JavaScript perspective. We have more plans long-term for how we want to tackle it, but we needed to get something in place to have some kind of reassurance when it comes to the JavaScript security side of things. And if there is a JavaScript security tool out there that I don't know about that's free and open source, let me know because I'd love to implement it, but I've searched high and low and haven't found anything great. So, so moving on to fuzzing, a lot of folks are probably familiar with AFL fuzz. It's a C-level fuzzer. It's found a ton of issues in things like OpenSSL and SSH and all different kinds of C-based functions. So there's a package called GoFuzz, which is based on AFL fuzz, uses a lot of the same kind of intelligence. And for anyone who's not familiar with fuzzing, more or less, it's throwing random data at a function and seeing what breaks. There's a lot more to it than that, but that's kind of the very high level is this fuzzer will hook into the process, look at the data flowing through it, throw a bunch of random data. It's usually built off of some kind of legitimate data, and just keep doing that until something breaks, and then trace out why it breaks. And so, like we were talking about, we have custom level or custom network protocols that parse packets, just raw packets coming in over the internet. So those are kind of things that have a lot of complex logic to them, and they're taking in random data. And we've seen pretty much every piece of internet-facing software, FTP implementations, SSH, everything's had issues with buffer overflows and other security issues. So we want to have some kind of some reassurance that these applications are doing a good job in terms of parsing this data. So it's a really awesome project, GoFuzz, up on GitHub, and relatively easy to include in your project. We actually have an open source script implementation for Go, which I think is the only implementation out there for password hashing.
It's not the only, but
it's the best.
Sure, yeah, we'll say that.
Yeah. So this is a fuzz function that we're basically wrapping around our compare and hash password function and our generate from password function. So this is just two of the functions in the script library that take in a password and then do some, they hash it or they do a comparison. And so it's relatively easy to hook in GoFuzz to your application. You just wrap the function you want to fuzz with this fuzz function. You pass in the data, which is what's generated by the by GoFuzz, and then you pass it through to your functions. And then you do some catches to see, if something returns an error or something returns the response type you don't expect. You throw an error, and then you'll get a whole stack trace, and you can go through that and figure out what happened. So we've had pretty good success with this. And if you want to check out this project that has it implemented, it's up on GitHub. The URL's at the bottom. It's in a fuzz branch on GitHub, so you can check it out. So yeah, you basically, to get GoFuzz started, you do a build, which hooks the fuzz function with GoFuzz, and then you just let it go. We've used kind of some beefy boxes to just run this in the background and just see what it comes up with. It'll sit there and start up parallel processes to just like hammer on this function, and it'll spit out the thing that crashed the function and also the stack trace, so you can see what broke. So it's really, fuzzing is kind of taking over a lot of security for different kind of areas. Google has a huge fuzzing farm that they throw a ton of different products into and just see what comes out of it. GoFuzz has, if you go to their GitHub, you can see the list of things that they have found in different open source products. So it's pretty cool to use, and it's kind of a good way when it comes to a language like Go, where there isn't great SCA tools, there isn't great support in the even in the commercial tools to get some sense of security from a Go function.
Yeah, I just wanted to take a quick step back. We were talking a lot about automation, but one of the important things that we do is we include sort of security reviews in our pull requests. So anytime a developer wants to push new code into master, they have to go through the PR process. Now this involves all the standard checks, does the code do what we asked it to do? Is the feature implemented properly? But also, are you introducing anything, anything unexpected? And we find this is, kind of wanted to touch on this because it's often overlooked. But having your developers or even somebody else, with maybe a little bit more experience in, if you happen to have somebody with the more experience in maybe like source code analysis or something like that, or even just has that interest in security, just have them take a look at what's being pushed through. People learn from people and other people's mistakes. Pretty early on, one of our junior developers was doing something pretty silly, and he was basically concatenating some strings into a SQL query, something we all know you shouldn't do, but he didn't really have the experience behind that. So what did we do? We caught it in the PR process. We talked about it. We talked about solutions, other ways to approach, building SQL queries and that sort of stuff. And over time, the number of what the fucks out of him dropped significantly. So, I just wanted to reiterate the importance of non-automated approaches to security as well. That said, so like as you're building out your process, choose your dependencies wisely. There's a lot of options out there. I'm not going to say pick the one with the best stars on GitHub or something like that, but that is an indicator. There's some value in researching the dependencies that you're using, seeing what other people are say about it, see what kind of open issues. Are there open security issues? Are there closed security issues? How did they address those? How quickly did they get through that? Those are all important things when you're choosing a dependency for your project. So that said, what can we do when it comes to dependencies and your continuous integration? We want to get back to the automating part of it. So right here, we've included a couple things in our CI pipeline for security. One of them is some dynamic testing for our front-end applications. CodeShip allows you to sort of build out your environment in a descriptor, a YAML descriptor, and also in a separate one, define how you want to test it. And so right here is a really simple application. It's a front-end application that we have, and what we're doing is we're adding in some Zap dynamic analysis to catch some quick low-hanging fruit, make sure nothing silly is going on. But we're also adding in this thing called the Node Security Project, or NSP, which does dependency checking to make sure that every time we push a build, there aren't any new vulnerabilities in any of our dependencies. So pretty recently, Express, which is one of our dependencies, one of its dependencies had a vulnerability. The MIME dependency had a denial of service discovered in the regex for MIME types, and our process got that right away as soon as it was made available, and we were able to make a decision about what to do about it. Now, for us, at this point in time, denial of service isn't really a big deal, but in the future it might be, or if this was something else, say remote code execution or SQL injection or something like that, it's really nice to be notified about it as soon as possible. So we're going to segue a little bit into sort of some of the infrastructure challenges that we have. So I mentioned earlier, Amazon is a great tool. It provides infinite number of services for you to do interesting things with. As they probably would want you to do, they have you build out your entire applications just directly using their services rather than anything else. But there's a lot of complication there. There's a lot of moving parts, and keeping track of all that can be difficult. In addition to that, when you're building out, like, just say an instance in Amazon's EC2, you're relying on a third party to provide at least the beginnings of that for you, or you don't necessarily have to, but it's an easy way to get started quickly. And yeah, so just going to talk a little bit like when you first start with Amazon. What are the things that you can do right away to kind of help yourself out, make yourself a little bit more secure? Number one, separate out your production and any development or staging environments into separate accounts. Don't make multiple VPCs in the same account. Reason for this is, development, staging, those environments get real messy. You make changes rapidly, they aren't tracked. It's really not, people are kind of loose with their keys and all that sort of stuff. You don't want a mistake in staging bleeding over into your production environment. So separate your accounts. Use something, Amazon has this capability called consolidated billing, which is basically you have one account, which is your billing account, and then all your other accounts are tied back to that. That way you don't have to worry about managing billing across all these accounts, but you can manage different environments across them. The second one's kind of a no-brainer. Don't use the root credentials. They're very powerful. They can be abused, and when you're using something like that, they often get shared. You really shouldn't, you don't want to be sharing powerful credentials like that. So what we do is we kind of set it aside in a vault and don't touch it unless we absolutely have to. There are a couple things that you'll have to set up through Amazon, especially on like billing monitoring and that sort of stuff that kind of has to be done through the root credentials. But in the end, we try to avoid using them at all costs. In addition to that, I'll jump down a little bit. Add your multi-factor access to it. So add a token to your root account so that whoever is using it has both, and you can have some level of assurance that it's being used for the right reason. And in addition to that, alert. Set up some CloudWatch alerts early on about access to your root account. I don't think we've ever seen an alert for it, because I don't think we've ever actually used it.
Pretty bad.
But I think I'm sure we tested it, right?
Yeah, we've tested it.
All right. Okay. Cool.
We're going to tell them we tested it.
Yeah. But yeah, those are some early on things that you can do. In addition to that, when you're creating like accounts for other users, enforce rigorous password policies. Organize everything in groups. Don't add policies to users directly. And leverage policy conditions to sort of restrict access into your environment. Real quick, Amazon has like a nice little checklist around their user accounts and stuff like that, making sure that that your users have two-factor enabled, that you're not sharing accounts, that sort of stuff. Make sure all the check marks are green. Set up as rigorous a password policy as you can. Console access is really powerful. You don't want unauthorized people getting in. And lastly, this is probably a little more interesting, is you can set up policy conditions to say like console access can only come from your VPN per se. Like can only come from a specific IP or IP range, or can't come from a specific IP or IP range. We set that up so that Mike and I, we're admins. We need to be able to do a lot of different things in there, but we make sure that we're only coming in and doing it through our VPN, so that we have some level of assurance that it is us, in addition to all the other logging and stuff we got going on.
Yeah, one weird thing I'll say about that is that you can log into the console even if it's restricted to a different IP, and you can surf to different services, but when you try to make a state-changing action, it'll say permissions not allowed, even if you're like star admin on everything. AWS is a little weird like that, and it's kind of not applied 100% the same way across different services, so you'll see some weird stuff. I often log in, I'm like, Brian, did you screw up my access? And then I realize I'm not on the VPN, and that's why I can't access anything.
And one other short note is like a policy like this, we use star for our admins. We don't use this for all the users, but this, back to the root account, this doesn't actually give you access to everything in the Amazon world like you would think it does. So there are some things out there that you do have to go back. Or when we have a little bit of time, maybe make some more specific policies for those explicit actions that we're not able to access with this.
Yeah, so another kind of just best practice, so in the same way that we can only access the console through one IP, we can only get to our actual infrastructure through one IP as well. And we have one box sitting on the internet, well, not sitting on the internet, but accessible from outside the VPC, which is our jump box. I mean, jump boxes are pretty standard practice, but you'd be amazed how many startups have just EC2 instances sitting out there with web servers or different things. And so you should have a jump box in place, but that's the only way to get through. And then if you can limit that to an office IP or a VPN, even better. I mean, our biggest thing is just trying to reduce the attack surface for our AWS environment as much as possible. And then on top of that, we have very few people. There's 3 people who can access our AWS environment. And whenever someone does, they both have to have a key on the jump box, but also Duo access. So there's a Duo PAM plugin that's super easy to implement that'll give you push notifications on anyone trying to log in. There's also a cool project to do Slack alerts for anyone who jumps onto the jump box. It's another PAM module you can implement. Really easy. It's just a bash script that runs on login that gives you Slack alerts. So you can see in this screenshot that Brian and I both jumped onto the jump box at one point, and we have just a Slack channel that has these alerts that tells us when someone jumps on. And so again, this is kind of a very high-level view of our infrastructure, but pretty much the only thing that is internet exposed is really our customer interface, and the jump box, which is only on our VPN, and then our ingestion services. Everything else is tiered off into kind of segmented networks with subnets and security groups. And that way, even if you're on one subnet, you might not actually be able to access a different one. So it's kind of just how we've structured it. And it's not, with security groups and subnets, it's not very difficult to set this up. So it's a good practice. Don't build your environment as a flat network, because in 5 years, when it's 3 times as big, it's still going to be a flat network.
Oh, you want to say? It's hard to hear in the back. Okay. Hold up a little higher, Mike.
Yeah, sorry. So yeah, and then kind of Brian touched on this before, but we have alerts set up for AWS to do things like console failed logins, root account usage. So if for some reason your root account credentials get leaked, we'll get an alert basically saying that they're being used. But we do see the console failed login here and there if someone just doesn't remember their password or has the wrong password. So these are super easy to implement. There's a guy, Ken Johnson, who did a talk on this called the AWS Survival Guide that goes over a lot of this kind of like basic AWS setup stuff. It's worth checking out. It's up on SlideShare, so check out those slides. But there are easy ways to use CloudWatch to implement these kind of alerts so that you know when certain actions are happening. And logging, just going to cover this really briefly, but I mean, it's really important from the IR work that I've done. It's really important to have logs. I mean, when some security event happens, logs are your only hope. And so having quality logs, a large amount with a long history, and having them centralized somewhere that can't just be wiped out is hugely important. In this day and age with both CloudWatch and Splunk, and there's a free version of Splunk, so you don't have to pay the $1 million license to have unlimited storage, but you can get a lot for very little money. We don't pay for Splunk, but we use it quite a bit, and everything's going to CloudWatch and Splunk. So we have 2 different places where logs are going, so even if one gets wiped out, we have a backup. And that's really powerful for figuring out what's going on, just from an application monitoring perspective, but also from a security perspective. And there's a really good AWS Splunk plugin too that you can implement. The only thing I'll say about that is it asks for a huge amount of permissions on your AWS account. That's not, that I don't really love, but you can limit that to only the ones that you want it to monitor.
So let's talk about building out the infrastructure a little bit. In anything you do, you kind of want to start least privilege, right? So when you're building out an image, you want to start out with the smallest footprint that you can. Strip down, whatever you start with to the bare minimum. Make sure, in our case, we take off pretty much everything, and the only real application service we have running on our instances is, aside from security tooling, is like Docker. We don't have any interpreters or anything like that. We take it all out. Now you can build on that later when you need to. You really want to organize your security groups in Amazon. They can when you're talking about least privilege, you want to be very specific about what types of instances can talk to other types of instances or other services within Amazon. And that can get out of control. There can be a lot of them. So you kind of really want to get down some sort of organization for that. One thing that we didn't do when we started that we really wish we did was create your infrastructure as code. I'll try to explain a little bit later and reiterate is, when you have all those security groups, all those moving pieces in Amazon, it can get out of hand, and you can lose track of what's happening. When you create your infrastructure as code, then you have a better handle on it, or at least potentially. And then lastly, let's talk about secrets, and also a very powerful tool that Amazon has, IAM. IAM controls access to everything, and you can leverage it very heavily to make sure that instance A can only talk to this Redis cluster, or instance B can pull out some secret from a data store, or can invoke some Lambda function. IAM is very granular, or can be, and should be used that way, or at least that's the way we see it. One of the tools that we use sort of for the first thing is stripping down and starting over the images. We use Packer. Packer by HashiCorp, which offers a lot of great tools. Allows us to define exactly what we want our images to look like. It allows us to rebuild them very quickly whenever there are security updates, or we need to introduce something else. So what do? We strip it down to the bare minimum. We incorporate our monitoring and security tools like Splunk, CloudWatch, OSSec, Duo. We add in the public keys for those that should be able to work within that environment. Very limited in our case, and should be in all cases. But we make sure that those are in the base image, so that anytime a new one's deployed in our environment, at least one of us can get on it and administrate it if we need to. And then from that, use that base image to build all your custom images. So if you need to deploy a Node application outside of this, take this and use it as your source, and build on top of that. Add in the dependencies and create another image. We do that. We use our base image, and then we do exactly that to add Docker to it. And we do exactly that for a custom Python application that we have. Just to kind of demonstrate, Packer definitions are built out of JSON, pretty easy to read and understand, and allow you to incorporate other images and other AMIs in order to build upon. So let's talk about security groups a little bit. Definitely adopt a consistent naming scheme so that when you're looking in the console, you can figure out what's what and who's talking to who. Update the default. So what we do is, for the Bastion host situation that we use, that Mike talked about earlier, we have one security group for that type of host, and we configure our default host so that default security group so that so new instances, when they're incorporated with it, are only allow access from that jump host or that Bastion host over SSH. And then continue to apply security groups to instances and other things in AWS with least privilege in mind. Always be building up. So again, we didn't do this, and we really wish we did. When you have as many services as we do with different permissions and privileges, it gets out of hand really quick. Something like Terraform, there are other tools out there, allow you to create your infrastructure once in code and deploy it anywhere. It also allows you to track changes and do pull requests to make sure, and reviews to make sure that the infrastructure changes you're introducing make sense. Don't introduce anything silly. So this is something that we've been investigating recently, and think it's a pretty powerful tool. Lastly, managing secrets. So this is a really big topic for us, something we started with really early. And in just really quick, obviously you don't want to store your secrets anywhere in plain text. Definitely not Docker, definitely not in a Docker image, not in your GitHub repositories, not in an AMI, and not in an S3 bucket. Like, those are just places where somebody's going to find them someday and have access to your infrastructure. Look for available services to help. So, Amazon has KMS, which does encryption for you. You can encrypt your secrets and then decrypt them on the fly when you need to. Leverage something like a Lambda function to do all that. Amazon has something that's, I'll talk about in a little bit, called parameter store, which allows you to store encrypted secrets and retrieve them later. And lastly, HashiCorp has this thing called Vault, which is a password manager for your infrastructure. We've looked at that a little bit, but I've never found that it was right for us, but it doesn't mean it's not right for somebody else. So let's talk about what we do. As we mentioned, like, developers are always pushing code. Everything, our staging environment is updated daily, if not hourly. And so we need a system to, deploy those new containers pretty rapidly. So what do? So when a user or a developer checks in code, it goes, CodeShip pulls that in and runs all our tests. At which point, it builds an image and it pushes that out to Amazon ECR, the container registry. If all that's successful, it will trigger a Lambda function. And this Lambda function is kind of the secret sauce, I suppose. It does all the things. So it'll pull encrypted secrets out of S3. It will request, based off of IAM roles, to decrypt those, and then it will push out new container tasks to ECS in order to deploy those into the staging environment. Now, a lot of this is managed by IAM roles. CodeShip has its own IAM role, and is only allowed to do two things in our infrastructure. It's allowed to push images, and it's allowed, push and read images for testing purposes, and it's allowed to trigger this one Lambda function. In my research recently, and Mike, you pointed me to this, we found this blog post called "The Right Way to Manage Secrets in AWS," and they actually have a lot of really interesting points that we were thinking about adopting. But Evan Johnson over at Segment introduced me to this thing called the parameter store. It was kind of hidden away, and I tried to show it here in the image because it took me a while to find. But in EC2, there's this, all the way at the bottom, there's this thing called the parameter store. And it allows you to store strings, encrypted strings, all that sort of stuff, and then grant access to them via IAM. So this is a really cool blog post. I definitely recommend it. And if you're looking for a way to manage secrets in your environment, it looks like one of the better ways to go.
Yeah, so that's kind of the things that we have done up until this point. And I'll say, like, all the things we've talked about we didn't do from day one. A lot of it we kind of did, the security hardening of AWS. That's stuff we tried to build in from day one, but we kind of iterated and we improved things as we went along and built things out. So next steps, we always want to continue to improve our security posture. So we want to add more alerting. We have a decent bit now, but we want to add more alerting for security events like in our applications, things like failed logins, or someone trying to access a resource they shouldn't have access to, something like privilege escalation. Like Brian talked about, we want to move to Terraform for all of our infrastructure. We want to be able to quickly rebuild our AWS environment if we have to, along with push out new instances and new networks pretty quickly. We also have some plans for kind of some custom static analysis rules for the different languages that we're working in. Like I talked about before, there's not a great solution yet, so we have to kind of home grow some of this stuff. And the other thing is that I've kind of looked into is using AWS Spot instances to kind of automate fuzzing. Fuzzing works when you throw more power at it, so we want to figure out a way to basically bring up spot instances, and if you're not familiar with those, you're basically bidding on, you can bid on AWS resources, EC2 boxes, and you make a low bid. If that bid gets chosen, you can use a big EC2 instance for pretty cheap. So we want to automate that to scale our fuzzing and have that running pretty much continuously. That's kind of the long term for exfil and security. But kind of in conclusion, what we kind of want to get across today is that security is tough. You know, the work that we've done has not been easy. It's not like this has all been, you know, half a day of work and go drink some beer. Like this has taken months, if not years of work to actually get to a decent place. But for startups, it doesn't have to be expensive. You don't have to go out and buy, you know, sorry, any vendors who are in the room, but you don't have to go out and buy, you know, a security tool. You don't have to buy a bunch of boxes to shove in your network. You can do a lot with what you have. There's a ton of great resources online, tons of open source tools. AWS itself is pretty much a security tool in a lot of ways, Lambda, IAM, all that kind of stuff. So you don't have to go out and spend a lot of money. So you just use what's available and always start from least privilege, build things with security in mind, and iterate and review. We're always building new things, new services. For us, roll out every couple months, new applications, new features. And so we always kind of iterate and review. We have new challenges, and we review what we have before and see how we can improve things. So we suggest those are kind of the ways you should tackle startup security in your company. So thanks for listening. If you want to read more about kind of this stuff, we have a blog up there, and we have a whole series of blog posts kind of how we've done AWS security for the past 5-ish years with this company and with ThreatSim before exfil. So thanks a lot for listening.